All right, let's jump right in. We're talking about the future of how we build, well, pretty much everything. From these massive structures you see every day, all the way to spare parts being printed literally in outer space. The way we make things is going through this absolutely insane revolution, and that's what we're diving into today. So here's the plan. We're going to start with some seriously cool finished products, the wow stuff. Then we'll get into the nitty-gritty, how you cut metal, how you stick it together, and what materials you use. After that, we'll see how AI and 3D printing are just pouring jet fuel on this whole process. And finally, we'll take a peek into the future. All right, first up, let's start with that wow factor. What can we actually do with modern fabrication right now? Well, the short answer, almost anything you can dream up. Okay, so take a look at this. This is not some artist's concept. It's a real restaurant in Dubai. And to get that amazing canyon look, it needed over 10,000 unique parts. Think about that for a second. With old school methods, you'd have to make a custom mold for every single one of those pieces. Can you imagine the cost, the time? It would be a total nightmare. But with digital fabrication, you just print each piece exactly as you need it, on demand. And it's not just about complex shapes, it's about mind-bending speed. In Japan, they put together an entire bullet train station overnight. Yeah, between the last train at night and the first one in the morning. How? Because all the parts were made somewhere else with insane precision. They just brought them in and slotted them together like a giant Lego set. And get this, it cost about half of what a normal concrete station would. So seeing stuff like that makes you wonder, right? How is this even possible? How do you build the impossible? Well, it all comes down to the fundamentals, the absolute basics of how you shape stuff and how you join it together. Okay, let's get into those fundamentals. The first big decision you have to make on any project is a simple one. How are you going to cut your metal? And trust me, this choice changes everything that follows. So you've got a few main ways to do it, and it's all about trade-offs. You've got lasers, which use heat to get these super precise, smooth cuts on thinner metals. Then there's the water jet. It's a cold process. It just uses high-pressure water to erode the material. You can cut almost anything with it, and it doesn't cause any heat damage. The edge is super clean. And then you have plasma. Think of it as the brute force option. It's ridiculously fast on thick steel, but you're going to have a rougher edge that needs to be cleaned up afterward. Okay, so your pieces are cut. Perfect. Now, you got to stick them together, right? And for that, we're looking at two classic methods that are actually really different from each other: welding and brazing. Welding is probably what you're most familiar with. The whole idea is to literally melt the two pieces of metal you're joining. You melt them down at the seam, often with a little filler material, and they fuse together. They become one single piece. And yeah, that makes for a ridiculously strong joint. Brazing, on the other hand, is completely different. It's more like using a kind of superpowered metal glue. You heat up the parts, but you never actually melt them. Instead, you melt a different metal, a filler, that flows into the gap and bonds them together. And this is a huge deal when you're working with delicate stuff, or maybe even trying to join two totally different kinds of metal. So it really comes down to this. What are you trying to do? If you need pure, brute strength for something structural, like a building frame, you're going to weld it. But if you need to be more delicate, or you're joining different materials, like in plumbing or electronics, brazing is your go-to. But, all this cutting and joining, it doesn't mean a thing if you're using the wrong ingredient in the first place. You have to pick the right material. And in the world of metal fab, there are really three big players that dominate. And choosing between them is always a balancing act. You've got carbon steel, that's your workhorse. It's strong, it's cheap, but yeah, it'll rust if you don't protect it. Then there's stainless steel. It's durable, has that clean look, and most importantly, it fights off rust like a champ. Think kitchens and medical gear. And finally, you have aluminum, the lightweight champion. Super high strength for its weight, and it's naturally rust resistant. So the question is always, what's the job? A bridge? A spaceship? That's what tells you which metal to pick. Okay, so we've got the basics down, right? Cutting, joining, materials. Now let's zoom out again, because there are two technologies that are taking these fundamentals and just supercharging them. I'm talking about AI and what's called additive manufacturing, or as pretty much everyone calls it, 3D printing. And I want to be super clear here. This is not some slow motion change that'll happen over decades. People in the industry are saying this is a total rewrite of the rulebook for manufacturing. It's happening fast, and it's happening right now. So what's AI's role in all this? Well, you can think of it as the new brain of the factory. It does things like generative design, where the AI literally explores thousands of designs on its own to find the absolute strongest, lightest version of a part, stuff a human engineer would never even think of. It can predict when a machine is about to break down and schedule a repair before it happens. It can watch a 3D print in real time and spot a tiny error instantly. It's making the whole process smarter from start to finish. And when you combine AI with 3D printing, you get some truly mind-blowing results. Check this out. Engineers at Johns Hopkins created this prosthetic hand. It's a hybrid. It uses both soft and hard 3D printed materials, and it can actually feel the difference between textures with 98% accuracy. That means it can pick up something super delicate, but also hold a loved one's hand safely. It's incredible. And this revolution, it's literally going off-world. The European Space Agency is developing something called Cosmic Maker. It's a 3D printer designed to make stuff in space. This is a total game changer. Imagine not having to launch a multi-million-dollar rocket every time an astronaut needs a spare part. You just print it. This could be the key to long-term life in space. Okay, so this is all really cool, but why does it matter in the big picture? Because this isn't just some hobbyist tech. We're talking about a huge global industry that's not only growing like crazy, but also getting a whole lot cleaner. If you ever want to see how big a revolution is, just follow the money. The market for the equipment that does all this stuff is on track to hit nearly $83 billion. And that's because everyone, from car companies to airplane manufacturers to builders, is scrambling to get in on these faster, smarter, more flexible ways of making things. And what's great is that as the industry gets bigger, it's also getting greener. Think about it. 3D printing means you only use the exact material you need, way less waste. The new machines are way more energy efficient, and new systems are capturing pollution at the source. It's a win-win, driven by both smarter rules and by us, the customers, wanting more eco-friendly stuff. And you don't have to take my word for it. The financial data tells the same story. This shows how much the market values these fabrication businesses. What you're seeing here is a healthy, stable industry that's also growing. The profits are steady and the revenue is climbing. The bottom line, jumping on this tech isn't just a cool experiment. It's just plain smart business. So when you step back and look at it all, it's pretty amazing. We've gone from a simple weld on a beam to a 3D printed hand that can actually feel. The very building blocks of our world are being completely reinvented. We can now take an idea on a computer screen and turn it into a real object faster and more complexly than ever before. We've basically figured out how to make almost anything. So the only real question left is, what are we going to make next?